So we're still in 2.3 functions, but now we're going to look at the domain and range of a function. So first what I want you to do is I want you to write 3 words here. So we talked about this being the input, and this is the output. Sometimes we also say this is x and this is y. And then also we call this the domain and this the range. Oh, I spelled it wrong. A-I-N, domain, and this is the range. Okay, so sometimes we call this the input of the function, x, this is output, y, and domain and range. Okay, so here we have a function, and it looks like this. Usually we see equations looking like this, but a function, we just take the y off and replace it with, say, f of x. Could be g, could be h. But usually we use f for function, okay? And if we put these inputs in one at a time, so say we put the number 1 into this function. I put a 1 here instead of the x, then I'm going to go 2 times 1 equals 2, and out comes 2. If I put 2 into the function as the input, I'm going to go 2 times 2, which is 4. So I put one thing in, 3, 2 times 3 is 6, and 6 comes out. So always one thing comes out when I put it in. So that's my input, that's my output. Okay, so now let's do some examples. It says, what is the domain and range of its function? Okay, so first we're going to do, is it a function? So if you hear people talking in my house, it's because I had a big flood last night and they're fixing the flood. Okay, so let's look. I use my vertical line test because it's a graph, and I say, how many places does it touch? Now remember, a function only touches in one place. So if I move this along, you can see that it's touching my graph only in one place. So I can say, yes, it's a function. Okay. Now, for domain, I say, where does this graph exist on the x-axis? So over here on the x-axis, there's no graph. So this is -1, this is -2. So if I go to -5, and there's no graph over at -5. So I have to say, where does the graph exist on the x-axis? Well, it starts from -2, and there's a little arrow here. So it's going all the way to infinity. So my domain is going to be from -2 to infinity. Now there isn't any open circle or closed circle. Okay, so if there's no open circle or closed circle, then we just assume it can be equal to, and we put a square bracket. Okay, so now I have to say, where does this graph exist on the y-axis? So if I look at the y-axis, if I'm sitting at -2 here, and I draw a line like this, it doesn't touch the graph. But if I sit here at 1, 2, 3, I can go, oh, there's a point here on the graph, using y as 3. Okay, so you can see that this graph only exists in the positive side of y. There is no graph on the negative side. So my range, because remember x is domain and range is y. Y goes from 0, we're using the points 0 all the way up to infinity. And you say, why does it go to infinity? Well, see how this has an arrow in it? It's going to go forever and ever and ever and ever and ever, up, 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 up. So it's going all the way up to infinity. Okay, remember round brackets on infinity. So yes, it's a function because of the vertical line test. Okay, so let's look at the next one, half of a circle. So let's say, is it a function? It touches only in one place. Yeah, it's a function, because when I move my vertical line, I can see that it only touches in one place on this half a circle. So yes, it's a function. Now I have to say, where does, for the domain, I have to say, where does this graph exist on the x-axis? So here's my x-axis. If this is 2, then this is 1, this is 1, and this is -2. Be careful, because sometimes someone might say that's 4, because I can go 4 jumps. But they've set that at 2, which means every 2 jumps is 1. Okay? So if I sit over here, say at 3, there's no graph at 3. It doesn't exist over there. This half a circle only exists between -2 and 2. And remember, because there's no open circle or closed circle, I'm going to use square brackets because it means that by default it exists at that point. Okay? So this graph, this half a circle, only exists between -2 and 2 on the x-axis. So now I'm going to look at the y-axis. Where does this graph exist? Well, if it was down here, then it would exist down in the negative space of y. But it doesn't. It only exists up here. It only exists actually between 0 and 2. You can see that there's no graph in the negative side. So my range, which is y, only exists between 0 and 2. And remember, there's no open circle, closed circle, so I'm going to use square brackets. Okay. Okay, let's look at the last one here. Is it a function? So we're going to do our vertical line test and go, oh, it's only touching in one place. So because it's only touching in one place at a time, then I know it's a function. So yes, it's a function. So now I have to do my domain. My domain is, you can see domain is what are your inputs, what are your x values. Okay. So because it has an arrow on it, so because this has arrows on it, it means it continues the same pattern probably. So it's going to go up and down, up and down, up and down, up and down. Okay. And it's just going to keep going forever and ever and ever because it has these arrows on it. Now I'm making an assumption because it has these arrows that it's going to continue the pattern. If it didn't continue the pattern, then they'd probably make it go up if it was going to go up. But it probably continues this pattern. So because it's going to continue and continue and keep going blue, 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 up and down forever, it's going to go towards infinity on this side and negative infinity on that side. So my domain is going to be all of the x-axis, okay, from negative infinity to infinity. So now my range, remember that's x, my range is for the y values. Well, you can see that this goes up and down, up and down, up and down between -1 and 1. Up and down, up and down, up and down. It never goes above 1, and it never goes below -1. And so my range is going to be between -1 and 1. So all my y values are between -1 and 1. My range is for y. Okay? But sometimes we have sets of ordered pairs. And I know it's a set because it has curly brackets. And these are all ordered pairs. Okay? So we want to know if it's a function, and sometimes it's hard to know if it's a function when it's ordered pairs. So what some people do is they make a mapping, and they go, okay, 3, -1, 4, 2, 4, 5. 3, -1, 4, 2, and 4, 5, and then 6, 8. So you can see right away, if I cover up the output, you can see that if I push 4 in the vending machine, 2 things come out. So I have an input that has 2 outputs. That means no, this is not a function. Okay? So I'd say no, this is not a function. I can look here and say, oh, I have a 4, and if I push 4, a 2 comes out and a 5 comes out. So I can say no, it's not a function. But some people like to write as a mapping so they can see it easier. But now I want to do my domain. Now my domain is all my x values. And when I have ordered pairs, it's easy. I just take all the x values like that, and I put them into a set. But I don't write 3, 4, 4, 6. I don't write the 4 twice because it's a set. I don't need to write it twice. I just write it once. Okay? So now my range is just my y values. So I take -1, 2, 5, and 8. So it's easy when it's ordered pairs. All right, so it's not a function. Here's the domain and range. So now I have to ask, is this a function? So I cover up the output and I say, okay, this input, one thing comes out, one thing comes out, one thing comes out, and one thing comes out. So yes, it's a function. Okay. So now when I want to do my domain and range, all of these values are my x's. That's my domain. So I just write these here. And my range is all of these ones. So this is my range. Okay. The last one, is it a function? If I push -5, a 2 comes out. If I push 0, a 2 comes out. If I push 5, a 2 comes out. That's confusing because they're all 2's. So let's cover up the output and do it again. If I push a -5, one thing comes out. If I push 0, one thing comes out. If I push 5, one thing comes out. Well, only one thing comes out with each one, so yes, it's a function. It's okay that they're all the same thing. So all of these x's are my domain, and all of these y's are my range. Oh, this is a mistake. If it repeats in a set, I don't repeat the number. I just write it like this. Okay, I don't repeat them. So here is my range. It's just really one number. I could really write it like this, -5, 0, 5. If I push a -5, a 2 comes out. If I push 0, 2 comes out. If I push 5, 2 comes out. So I write it like that. Okay, you can write it this way or this way for a table or a mapping, but for a set, you should not write repeats. Okay, so let's do some examples. So it says, decide if each relation defines a function, and then give the domain and range. So really what it's saying is it a function? And what's the domain and range? Okay. So the first thing that makes it easy to find out if it's a function or not, this is just a nice line. It's a straight line. And how do we know that? Because the exponent on the x is a 1 and the exponent on the y is a 1. Okay, they hide, but they're 1. So if it looks like that, you know it's a straight line. It can look like this, like this, like this, like this. Okay, and if it's a straight line, it's a function, unless it's a vertical line. If it's a vertical line, it's not a function. Okay, so I can say right away it's a function. Let's graph it. And this is what it looks like. And if I want to do my vertical line test, this should have arrows on the end. I can see that as I move my vertical line, it only touches, let's see, here's my rule. A function, it only touches in one place. So yes, it's a function. Yes, it's a function. Now I have to find my domain and range. Well, when something is a line, oops, let's spell it correctly. When something is a line, the domain and range are easy. Okay? Because this line goes on forever and ever and ever and ever, I'm going to use the whole x-axis. It goes all the way out towards infinity and all the way towards negative infinity. So the domain is going to be like all my x's. And then my range, because it's going on forever and ever, you can see it keeps going forever and ever. my range is also going to be negative infinity. So if I have any plus 4y equals plus 10, that should be an x. This is a line because the powers are 1, okay? And it's not a vertical line, so you know this is going to be a straight line, so the domain and range are going to be negative infinity. If I have y equals a half x plus, I don't know, minus 4, you see the exponents are 1 on the x and y. This is a straight line, so my domain and range are going to be negative infinity to infinity. But if I just want to look at this, I can say, if I put in an x value, will one y value come out? So let's pick a number, 10. If x is 10, I put the input of 10, I go 10 plus 4, that's 14. So y is 14. Yeah, one number comes out. If I have a mapping, I put in my 10, and 14 comes out. Only one number comes out. So that means it's going to be a function. If I put in the number 100 plus 4, your answer is 104. So y is 104. So one number comes out, so it's going to be a function. Let's look at the next one. Okay, whenever you have square roots, it's a problem area. Okay, that means you're going to have to restrict the domain and range. And if you remember that a square root, when you graph it, it's always going to look like that. And it looks the same as a square root. So here's my square root, and this is what a square root looks like, or a radical looks like when you graph it. They sort of look the same. Okay? So when I look at this here, this is what it looks like when I graphed it. Let's see, is it a function? Yes, every time I move my vertical line, it only touches in one place. Touches in one place. That means it's a function. Okay? Yes. Okay. Now my domain, you can see my domain is for my x. My domain is x. So you can see that this starts somewhere, and there's no graph on this side. It doesn't exist. So my domain is, where does my graph exist on the x-axis? It starts here, and it goes towards infinity. So if this is 2, this is 1, and you can see that this is half. Right here, this is half. So it starts at a half, and it goes towards infinity. But that's because I have a graph, I can see that. What happens if I didn't want to graph it? Well, there's restrictions on radicals. This here, whatever's underneath my radical, cannot be a negative number. So this has to be bigger than or equal to 0. So what I do is I take this and I say it has to be bigger than or equal to 0. And then I solve for x. I put the negative 1 to the other side. I divide by 2. And I get this. X has to be bigger than half. Oh, I can see that. Yes, x has to be bigger than half. So you can graph it, or you can take whatever's under the radical and solve for x, and it will tell you what x has to be bigger than. So then I take this and I go, oh, x has to be bigger than a half, but it goes towards infinity. Okay? Now when we do the range, y. If I look at my graph, here's y. Y is 1, I have a graph. When y is 2, I can touch the graph. When y is 3, I can touch the graph. When it's 4, but when I'm down here, there's no graph. So you can see the graph only exists when y is 0 or bigger than 0. So because this keeps going on towards infinity, I say my range has to be from 0 all the way up to infinity. Now remember, we use a square bracket because we don't have any closed circles or open circles. And so we just assume it can be equal to that. Okay? But that's because I have a picture, all right? I can see that easily. But say I wanted to just look at my equation, okay? And I wanted to go, okay, what's my range from this equation? So I look at this and I go, I can't have any negative numbers. When I take the square root of something, say I take the square root of 100, well, it's a positive number. I can't take the square root of something and get something negative out of it. So I have to sort of use a thinking process to discover that square roots of things are always positive. I can't get negative numbers, and so y can never be negative. So that's how I can do it through thinking, okay? Or you can just remember, bloop, they look like this, okay? And then you can sort of graph it. You can use graphing software to do this. Okay, let's look at my next question. We have to say, is this a function? So I've graphed it, okay? And I can see that when I move my vertical line, it touches in two places because it's a parabola on its side. So I know that it's not a function, okay? But maybe you don't want to graph it. You just want to use this equation and say, well, how do I know it's a function or not? So what you can do is you can say, okay, I'm going to put a number in here for x. So let x equal 4. I'm just taking a nice easy number that's a square because I see a square, so I think I might need a square. I could use like 9 or 16 or 25. Doesn't matter. I'm choosing a square because I think I might need a square because I see a square. So I can go y squared equals x. I'm going to put the 4 in for the x. Y squared equals 4. Now I have to solve for y. Y squared equals 4. So I'm going to take the square root of both sides. And so those sort of cancel each other out. And I'm left with y equals plus or minus 2. Oh, so if I put in a 4, I can get a 2 or a negative 2. That means no, it's not a function because if I put in my 4, I get two different outputs. Okay, so you can do it by looking at the picture, or you can do it by just putting in a nice number and solving and see what happens. Okay, so now my domain is x, my range is y. So if I look at my parabola laying on the side, I can see for x, these go on forever, x has to be bigger than 0. There's no graph on this side. So it has to be 0 or bigger. Okay, range, because this goes on forever and ever and ever, that means you're going to use all the y's up to infinity and all the y's down to negative infinity. Okay, or you can look at this and go, what y can I put in here? I can put 10 in. 10 squared gives me a number. I can put 100 in for y. 100 squared gives me a number. I can put 5,000 in there, or negative 200. I can put any number in here and it can be squared. And so that's why I know I can use any number. Well, for the domain, if I don't have a graph, let's look at the domain. So if I want to know what numbers I can put in for x, I'm going to solve for solve for y. So let's get rid of this squared. Look, really, it's like a square root hiding in this idea. There's a square root, there's a radical. So if I solve for y, I can see that there's a restriction on x. X has to be bigger than 0 because it's a square root. I can't put negative numbers in here and get an answer. I can only put positive numbers in here because it's a square root. So I can see by solving for y, I can see that here x has to be bigger than 0. Okay, it can be 0, but it has to be 0 or bigger. Okay, so this is another way to do your domain. So you can do it through a picture, or you can do it by solving for y. Okay. Now, okay, next one. So this is an inequality. That's when you have less than, more than, less than or equal to, greater than or equal to. And whenever we have an inequality, it's not a function. You don't even have to look at anything in there. You don't have to look at the numbers or anything. You just go, oh, I see an inequality. It's not a function. Why? Because if I do my vertical line test, like here's my inequality. It's always going to look something like this. It might be a dotted line and then colored. It might be colored above. Maybe it'll be, a dotted line and colored above. So it might be colored below, colored above, solid line, or dotted line, okay? But when I do my vertical line test, look, it touches at so many places. And what's the rule? It's not a function if it touches in more than one place. So inequalities are always colored in. And you have this big chunk of an area. So you can see that my vertical line touches in many, 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 many places. So inequalities are never functions. Okay? So now if I do domain and range, let's take out the inequality sign and change it. Change it just into this. Make it an equal sign. Because the exponent is 1 and 1, I can see that this is just a straight line. It's a straight line, see? Straight line. Which means it goes on forever and ever and ever and ever both ways. And straight lines, the domain, because it goes forever and ever, we're always going to use all of our x's on the positive side and all of our x's on the negative side. And the same for the y values. It's just going to keep going and going and going and going and going and going. So whenever you have a straight line, easy for domain and range. Okay? Now we have fractions. Okay, fractions, it's called fractions when there's no letters. And it's called rational expression when it has letters. So 5 over x minus 1. It's the same thing. It's a fraction. It's got a top and the bottom. So when you see something that's fractional, it's going to look like this, probably. Okay? So in your head, you have to remember this diagram, this graph. And it has a problem area. So when you see this, you have to go, I have to be careful. Okay? So let's just first check to see if it's a function. It says yes. Let's check. So if I go like this, it touches in one place, one place, one place, one place. Down here, my paper clip's not long enough. Let's make my paper clip longer. It looks like this is on one side and this is kind of further, so it's not touching in two places. It's only one place, one. So because it only touches in one place, I know, yes, it's a function. Okay? Now say I don't want to draw it. I want to just look here and say, is it a function? Okay, so let's check. Let's pick a number, easy number. Say, let's say 10. If x is 10, so I'm going to put in a 10 and see what comes out. 10. 10 minus 1 is 9. And then I have 5 over 9. Y is equal to 5 over 9. So like a fraction. So if I put in a 10, a 5 over 9 comes out. Well, that's one answer. Let's put in another number, 100. If I put in 100 as my input, 100 minus 1 is 99, and my answer is 5 over 99. So if I put in 100, my answer is 5 over 99, which is a number. So if I put in one thing comes out. So yes, it's a function. Because remember, you put one thing in, one thing has to come out, just like a vending machine. Okay? So now we have to deal with our domain and range. And this is where I go, oh, we have more work to do, because we have to find these problem areas. Because see how the graph has like a gap? It goes like I'm going here, whoa, I go down. And then there's a space here. There's a space here, and then it starts again over here. Same going this way. There's a space here. Okay? This gets closer and closer and closer and closer to something, but it never touches it. And this gets closer and closer to something, but never touches it. So, if I look at my x value here, this can never be 0. Because if I have a 0 on the bottom, I'll have 5 over 0, and that's undefined. When I have this fraction looking like this, undefined. If I put this in my calculator is going to go, what? That doesn't work, because you can't go 5 divided by 0. So what I do is I take this, and I say, you can't be equal to 0. And then I solve. Move this guy to the other side, and it gets, oh, x can't be 1. So if I look at my x, here's 5, so here is 1. So this comes, if I draw a line like this comes down and it gets closer and closer and closer and closer to 1, but it never actually touches 1. This goes up, 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 but it never touches 1. So this goes all the way out to infinity, all the way out to negative infinity, but it never touches 1. So we have to write it differently. We have to go, x's can be all the way from negative infinity to 1, stop, put it round bracket because it's not equal to, and then it starts at infinity and it goes towards 1, but it never touches it, so round bracket. And then we use this U that stands for union. You know, when two people get married, there's a union between two people. So this is the same thing. These two sort of get married, they get stuck together, and so we use the U for union. Okay? So now we have to say, okay, where's the problem area with the y values? So if I come down here, it gets closer and closer and closer to something, but it doesn't actually touch it. So what we do is we can take this and solve for x. So we'll go y equals 5 over x minus 1. And I have a cheat. All I do is I switch these two into different places. So this one goes here and this one goes here. So I go x minus 1 equals 5 over y. I just switch them. That's the fast way. And then x needs to be alone. So then I move this to the other side. So I have x equals 5 over y plus 1. So I solved for x. And I can see I have a fraction here. Well, it's really a rational expression because it has a letter. But it's fractional. And so I get this y down here on the bottom. Well, I know I can't have 5 over 0. I can't have this as a 0 because it'll be undefined. Okay? So I have to say y can't equal 0. Well, here I had to solve for something. Here I don't because it's just already y can't equal 0. So I can say that this goes all the way down, 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 and it gets closer and closer and closer to 0, but it never touches 0. And here it comes from negative infinity, and it goes closer and closer and closer to 0, but it never touches it. So that's why I have to say it goes from negative infinity to 0, round bracket, because it never touches it, and then it goes from, y. And then it goes from here to 0, never touches 0. Okay, and we have to use the union again. Now, some people do it a different way. They don't actually solve for x. They go, if I put big numbers in here, bigger and bigger and bigger numbers, what happens? So let's put 100 in there. Y equals 5 over 100 minus 1. Well, that's 5 over, you can't see what I'm writing. So I'm putting 100 in for there. Y equals 5 over x minus 1. So there's my equation. I put 100 in there. So y equals 5 over 99. That's a small number. Let's do it again. Y equals 5 over, let's say, 1,000,000. Is that 1,000,000? One more. Well, that's equal to 5 over 999, blah, 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 blah. That's getting smaller. That's getting closer to 0. Let's put almost infinity. Let's put big numbers, big numbers, big numbers, lots of big numbers, -1, lots and lots of 9s. That's 5 over a humongous number. So you can see that as I put in bigger and bigger and bigger numbers, if I put 5 over infinity, you can't really do that, but think in your head close to infinity, that's getting to be a very small number. Can it ever reach 0? No, but it's going to be pretty close. It's going to be pretty close, but it's never going to actually reach 0. So some people just do this in their head and go, this can't be 0. So that's why. So I'm just showing you different ways to think about this. Okay? So now let's do some examples. Okay. Is it a function? And what's the domain and range? So sometimes we just have ordered pairs, which are points. And look, I'm only touching 1 point, 1 point, 1 point, 1 point. So I'm only touching in one place. So yes, it's a function. Domain. Domain is the x values. Well, domain and range for ordered pairs are easy. I'm just going to take the x values and I'm going to put them in a set. And I'm going to try and write them from small to big. So -1, 0, 1, and 4. Okay, close my set. My range is my y values. So now I'm going to take my y values and write them from small to big. And that's it. So when it's ordered pairs, it's kind of easy. All right. Now let's look at, is this a function? Okay. I can use my vertical line test and I can see that it's touching 2 places at a time. So it touches more than one place. No, it's not a function. What's the domain? Domain is x. So where does the graph exist on the x value? So it exists, let's see, that looks like 4. 1, 2, 3, 4, 1, 2, 3, 4. Yeah, so that's telling me it's 4 here. So you can see that this ellipse only exists between -4 and 4. And because there's no open circle and closed circle, I'm just going to use square brackets. So it exists between -4 and 4. Now my range is the y values. Let's check if this is 6. 1, 2, 3, 4, 5, 6. Yeah, so they're saying this ellipse exists only on the y-axis between -6 and 6. And I'm using square brackets because there's no open and closed circles. So in this one, there's arrows, but it's hard to see. So as soon as I see it's a straight line and it's not vertical, I know it's a function because it only touches in one place. So yes, it's a function. And if you remember with domain and range for straight lines, easy peasy, because it goes on forever, so it uses up all the positive x's. It goes on forever, it uses up all the negative x's. It goes on forever, so it uses all the y positive values, and it goes on forever down, so it uses up all the negative y values. So straight lines are easy. So is this a function? This is a parabola, but it's facing up like a happy face. And is it a function? It only touches in one place. So yes, it's a function because it only touches in one place. Now the domain, the x values. So this is going to keep going forever and ever and ever, and it's going to use up all the positive x values until infinity. And this is going out like this, and it's going to use all the x values to negative infinity. So my domain, and remember for infinity, you have to use round brackets because you can never actually have infinity dollars in your bank account. It just doesn't work. Now, why? The range, well, because these are going up, It's going to keep going up until positive infinity. But look, it starts here. There is no graph down here. Well, what number is that? 1, 2, 3. So the graph only starts at -3 and then goes up. So it starts at -3 and then goes up. So I put a square bracket because it doesn't have open and closed circles. So it can be equal to that 3 there. And always use a round bracket at for infinity.